In this episode, I'm talking about 3D printing. Why it's more useful than you thought and easier than you think. Unless you're like me. Listen, 3D printing gets a bad rap. The media mostly covers all the silly and crazy things that can be made with 3D printers. A 3D printed car, candy, toys, cosplay, and figurines. Boring. The only thing wrong with any of those is how it marginalizes the utilitarian benefits that 3D printing provides. What? But you're here watching this video, so maybe it's predicated on a consumerism perspective of the technology. It's a thing I can buy that can make silly things. But the story should be sold as how it can improve our lives as a creative tool that inspires us to think, innovate, and create. I mean, this channel isn't about me just flexing on my maker skills. Well, a little bit, but it's about inspiring people and showing them what can be done with consumer-grade tools. Now, 3D printing isn't the only solution to innovation, but it's a vehicle which accelerates design, fabrication, learning, and innovation. And that's a powerful cycle. For most people, 3D printing is a novelty, something with little application in real life. I would suggest that 3D printers are one of the most useful tools in my arsenal, and if I had to start over, a 3D printer would probably be the first machine I'd purchase. In some cases, other machines and tools can be made from a 3D printer. Before we get too far along, let's just say there are several technologies that fall under the 3D printing umbrella, and most notable can be ranked from simple to complex like this. 1. Fused deposition modeling, or FDM. Thin layers of plastic are melted together to create objects. FDM has the lowest cost to entry, moderate surface quality, and a diverse array of materials. 2. Stereolithography apparatus, or SLA. A laser is used to solidify layers of resin in a vat to create objects. Similar to FDM, except SLA cures epoxy while FDM melts plastic. SLA can be significantly more expensive, which may be justified by the excellent surface quality that it produces, depending on your needs. And 3. Selective laser sinistering, or SLS. A laser is used to fuse powdered material to create objects. SLS is a high-end technology which can produce industrial-grade prototypes. That aside, for the purposes of this video, we're talking about FDM-based 3D printing. For the home users, 3D printers have real practical applications in our lives. The possibilities are endless. For starters, let's assume any ornamental thing can be created. That's a no-brainer. But once you've exhausted your interest with the gimmick of printing in 3D, your ambitions will change. You'll wonder if you can fix that broken plastic clip in your bookshelf, or make a trivet for the houseplants, or even making custom PPE. The possibilities are endless. Your mind could explode. As your projects become more complex, so do your requirements. When you start out, you may use PLA filament. It's easy to print with, but it has its limitations. You may need to use another type of filament to meet the needs of your project. Fortunately, there's a spectrum of filament materials to choose from, and each with its unique thermal and mechanical properties. Some are more rigid, others are flexible. Some are strong, others are brittle. High temp, low temp, self-lubricating, industrial, the list goes on and on. And there are lots of online tools. In fact, I have one on my website that I'll post in the comments below. This is something that you'll learn along the way, but know that some materials will work better than others for your application. The important thing to know is whether the printer you choose supports various types so that you have that flexibility. For professionals and makers, 3D printers may not be able to produce the final products that we make, but they do serve a purpose in creating draft representations of the final parts. This allows us the ability to test and prototype your design in a cost-effective way. In fact, I use 3D printers often for this purpose. Heck, I even use them to test a part before printing the part on a high-end 3D printer. As a material savings, it just makes complete sense for me. When I look at the 3D printer industry, there are printers at all levels: low cost, entry level, high-end, and professional systems. As a general rule of thumb, it's important to note that low cost almost always certainly means more work for you, but high-end doesn't always mean that it'll be less work for you. What is the cost of capability? It's complicated, so let's explain a few considerations. When you use 3D printers, they generally require other supporting technologies to work. One, you need to digitally model what you want to make. While there are plenty of resources online to share models, when things get custom, you'll need tools to model those custom parts. Fortunately, there are plenty of free tools to model anything you can think of. This part isn't critical, but chances are to get the most from your printer and innovate, you'll need to design something. Just know that there are all levels of modeling tools to get into the craft and learn at your own pace. 2. To tell the printer how to print your part, you'll need software to slice the model into layers which can be recreated by the printer. While there are free slicers available online, they need to be tuned for your specific printer's parameters and capabilities. Usually the company or someone in the community has created a printer profile that you can use, but if not, that's on you. You'll need to learn a lot of the terminology like infill, brim, shell, retraction, to name a few, and it'll take some time to research. 3. Next, you'll need software to send the slice model information to the printer in order for it to build the layers and print your object. There are a few free software packages that do this. Some of the software slicers will incorporate this capability as well. Low-cost and low-end printers will generally leverage freely available tools to perform all of the above. That helps to offset the price if you're willing to take on the technical challenge of learning all that stuff. But there are benefits to be had as you rise through the levels of quality in 3D printers. One thing you'll find is that 3D printing companies begin to simplify these steps and ease of use of their printers by incorporating these capabilities into their platforms. For example, the company may offer their own slicing software, which is pre-configured and designed to work out of the box with their printer. Some printers support wireless connections, allowing you to send data directly to the printer without having to transfer over a network or using a thumb drive. And lastly, some printers will support the ability to print an object offline without requiring a PC to feed the data to it. There are also a multitude of complexities that can be found, such as heated beds, multi-filament extruders, auto bed leveling, and more. At the end of the day, printers come in all shapes and sizes, assorted capabilities, and your needs determine the one that's right for you. Today I'm going to share an entry-level machine that shares many of the principles above, making it easy to get good results with minimal investment. It's called the Adventurer 3 and it's made by FlashForge. Full disclosure, a couple weeks ago I asked the company to send me a review model and they obliged. Over the past week I've really enjoyed using it. Definitely see an application in my shop for printing quick and small items, producing results comparable to printers that cost 5 times this device. This little guy weighs in at 24 pounds. And it has an outside dimension roughly 15 inches cubed. In the box with the printer comes a manual, a modest maintenance tool set, and a power cord. But where it shines is in design and ease of use. Let's run down the specs quickly. A fully enclosed build chamber. This normalizes the environment temperatures, preventing fluctuations which can cause irregular part cooling and shrinkage, which is all bad. A heated bed. Some materials need to be kept warm when printing to control the rate at which they cool, as well as promote bed adhesion. A built-in HD camera. To monitor your prints, of course. Wireless connectivity allows you to monitor and control your print remotely, without wires. Filament sensor to prevent runout. Self-leveling and removable bed. Removing prints is as easy as flexing the bed. Has a build volume of roughly 6 inches cubed or 150 millimeters. It's a little on the small side, but fine for most things you want to print. Has a 0.4 millimeter nozzle diameter and uses 1.75 millimeter, which is one of the most popular sizes. It natively supports PLA and ABS, among other similar composites, including metal filled, wood filled, and high-speed PLA. This will account for probably 90% of most people's needs. If you have more specific desires like printing TPU or flexible filaments, then you should probably look for another model of the device. This printer uses a Bowden drive, which basically means it pushes filament to the extruder, rather than pulling it like a direct or weight extruder does. While they work relatively good, they prevent you from using more exotic flexible filaments, just because it compresses when it tries to push it. The only immediate issue I had with the printer is that the filament spool is designed around a 0.5 kilogram spool. 99.9% of printing filaments is sold in 1 kilogram spools. So you either have to re-spool your filament to a smaller compatible spool, or do like I did and 3D print a spool holder extension to hold the larger 1 kilogram spool. See how useful 3D printers are already? I'm printing parts for itself. Once powered up, the menu provides an intuitive interface to the system. The main categories allow you to print a model or tools to calibrate and home the device, and of course manage the filament. The interface provides reasonable feedback to walk you through each procedure in a wizard-driven sort of way, which is easy to understand and follow. When printing a model out of the box, there are a couple methods to perform this. Clicking on the build menu item, you can read from memory or pull from a thumb drive. This is a nice option to run the machine in an independent mode. But keep in mind, if you plan to run it this way, you'll need to generate the print file for printing in advance. Fortunately, FlashForge provides a software application called FlashPrint. You can download it from their website for free, and once it's installed on your PC, you can use it to set up the models and generate the files for the printer. There are a few tools in the software which allow you to scale and rotate your model the way you want it printed. You can also add support or raft for complex objects. Supports are just scaffolding to brace the object while it's being printed, and rafts help give your model a solid footing to build upon. You may need these on a case-by-case basis, and mostly depends on the model's orientation and size. So now you can put the files on a thumb drive and walk them over for the machine to print. If you take the time to connect the printer to your wireless network via the Tools, Network, Wi-Fi menu, you can interact with your printer in a few new ways. One, you'll be able to send files directly from the printer over a wireless connection, making transfers easier. Two, you'll be able to configure cloud services including FlashCloud. This is FlashForge's free online printer slicing and management dashboard. PolarCloud. It's an educational institution and curriculum platform for collaboration, but with the caveat that you need to be enrolled in school. Or My Mini Factory, a decentralized ecosystem for 3D creatives where you can purchase and sell models. Make a few bucks. My recommendation for the best option is to head over to FlashCloud and set up a free account. This is going to greatly simplify your experience using the FlashForge printer. Once your account is set up, you'll see the simple interface with sections on the left including My Printers. This is where you can add and manage your printers to the dashboard. My Models. This is where you can upload your models that you want to print. My Jobs. This will show you any prints in progress as well as historical print jobs. And finally, Model Library. This is a community-driven library of models that you can download, print, and use. Though your mileage may vary, some of the models are not as necessarily suited for easy 3D printing. With the account ready to go, you get a registration code from your printer and use that in FlashCloud to register the device, and you're good as gold. Let's run this machine through its paces, printing a new Arcator 3 subframe and body. It's easy enough to load the files up to the cloud, but this can take a few minutes to process. When it's done, you can orient the object as needed on the build platform. Keep in mind, supports are needed if your model has overhangs. Adjust the print material and settings, and then send it to the printer. The rest is automated, and I can always go back and check the progress of the job on the cloud dashboard for the printer. When the job is completed, the build plate is pulled out and flexed to release the model. Next, we clean up the model by removing any supports using needle nose pliers. I was really impressed with the results on this printer. The engineers at FlashForge did a pretty good job at dialing in the print parameters for the machine. There's no over extrusion, no blobs, surface is smooth. With some minor finishing, this will be the beginning of another happy handheld. These are a few other items I printed on the machine at high resolution. It takes a little bit longer, but the surface layer quality is so much nicer you can barely even see the layer lines. Hopefully this was a useful overview of 3D printing and a promising entry-level 3D printer that, if you're interested, can help you get past most of the barriers. The innovation is up to you. The print quality is great and the ease of use is definitely there. Anyway, if you're interested, be sure to check out the FlashForge line of products. They may have what you need to get started. If not, be sure to compare it to other products and you may notice how unique this combination of features really is. Now it's up to you to get out there and build new things, innovate, bring your ideas to life, or just fix that light switch in the hallway. That's going to do it for this episode. Hopefully you found this useful and informative, or at least entertaining. If you enjoyed the video, give it a thumbs up. If you're new here, please subscribe to the channel and take it that extra mile and ring the notification bell. It'll help keep you in the loop on future updates. As always, it's just crazy with this virus out there, but this too will pass. In the meantime, be safe out there, have fun, and I can't wait to see you next time. Hey, if you liked the video, please subscribe to the channel. It's how we're building the community. Also allow me to bring better content. Also check me out on these other social networks. There's lots of cool stuff there too.